In example 5, we have a company that has initial costs of $275,000, and it also costs them $14.80 to produce each sprocket. They then sell sprockets for $26 each. Now this is a very simplistic example. We're going to go ahead and assume that they sell every single sprocket that they produce. So it asks us first in part A to find a formula for total cost. So of course total cost, will be their fixed costs, their initial costs, plus variable costs. So for this particular function, C of n, our fixed cost is the $275,000 plus variable cost. It depends on how many sprockets they produce. It'll be $14.80 per sprocket times n sprockets. So there is our cost function, C of n. Revenue is cash in hand. It's different than profit. Revenue is just the cash they received by selling their sprockets. So revenue is price per item times number sold. So how many they sell times the price per item. So for our R of n function, price per item will be $26 per item times n items sold. Profit is cash they made minus cash they spent. So it'll be your revenue minus cost. So for us, our profit, P of n, is the revenue function, 26n, minus the cost function. Don't forget to put parentheses around the entire cost function. So we're distributing the negative. So once we do that, P of n equals 26n minus 275,000 minus 14.8n. And then we see that we have like terms, 26n minus 14.8n. Those will be like terms, and overall we'll get 11.2n when we combine those together, minus the 275,000. And there's our profit function. It asks us to identify the break-even point. So how many do they need to sell to go from a negative profit into positive profit? So we need to find the number sold when the profit equals 0. So we have a profit function, and we're going to let the profit equal 0 in the profit function, and we're going to solve that profit function for n. We add 275,000 on both sides, and then we divide both sides by 11.2. I'll just pull out my calculator and divide that out. 275,000 divided by 11.2 gives us approximately 24,553.57143. So I'm going to say 0.6. That's about n. Now remember, n stands for the number of items sold. So if they were to sell 24,553 items, they'd still be in the red. But if they sold 24,554 items, they would just go into positive profit. So I'm going to say 24,554 items. We'll put them out of the red. In example 6, a company makes a total profit of $145,620 when selling 8,400 widgets. They increase profit by $13.25 for every widget sold. Find a formula for the profit. Our profit function, if we think about input and output, it will input number of widgets sold, n. It will output P of n, profit. The first thing we always want to think about when writing the equation for a function like this is we want to ask ourselves, what type of function is it? Is this a linear function? Is it exponential, quadratic, logarithmic? What type of function do we have here? I'm going to go back to the information given and see if we get any clues. In the second sentence, it says they increase profit by $13.25 for every widget sold. If we were to pick a point on this graph, let's say there was a point here on the graph, The description of the second sentence is saying, if you increase one widget, so over one widget, it's going to go up $13.25 in profit, and then you'll land back on the profit function. And it says that they do that every time. They increase profit $13.25 for every widget sold. So on the graph, it's saying over 1, up $13.25, over 1, up $13.25, and so on. They are describing a straight line, a linear function. That is the sentence that tells us that. So I know it's linear. And specifically, that sentence is describing the slope. Remember, slope is change in output divided by change in input. So the change in the input is over one widget. The change in output is up $13.25. $13.25 per widget. All right, so what about the first sentence? The first sentence is telling us a point on the graph. They tell us specifically the profit is $145,620 when selling 8,400 widgets. So if the input N is 8,400, the output P will be $145,620. Now we have the slope of the line and a point on the line, so we can find the equation of the line. Recall, you can write the equation of a line using the point-slope form, where you plug in the slope for m, and you plug in the point for x1 and y1, and so I'll just write it out. P of n equals, the slope is 13.25, parentheses. Instead of x minus the x1, our x is really n minus the x value of the point is 8,400, plus the y value of the point is 145,620. So there is the equation of the line. Now, if you prefer, you certainly can distribute the 1325 and gather like terms, but it's okay to leave it like this. This is the equation of a linear function with slope 13.25 that passes through the point 8,400, 145,620. Example 7. Demand for widgets at Acme decreases by 4.2% for every dollar that they raise the price. They're projected to sell 45,000 widgets when they're free. I put sell in quotes because if they're free, they're really giving them away, not selling them. And it says to find a formula for D of P, which gives the number sold when items are priced at P dollars each. So again, just make sense out of input and output first. P is the input of D of P. P stands for price of items in dollars. D of P is the output. D of P stands for the number of items they sell. So we would go along the input axis and say they're charging $1 per item, $2 per item, $3 per item, and so forth, and it would tell us then how many they sell if they're charging that price. All right, from the given information, the next thing I want to do is figure out what type of function that we have. The first sentence is giving us the information we need to understand the type of function. It says, demand decreases 4.2% for every dollar they raise the price. So again, let's come over here to the graph. Let's suppose this is a point on the graph. They're saying if you go over $1 on the price, so over 1 on the input, it will go down 4.2%, not 4.2 items, 4.2%. So it would go down to here. Then again, it would repeat over 1, and from that height, go down 4.2%. Now that's not going to be the same amount of decrease. It would actually be smaller amount of decrease. Then again, over 1, down 4.2%, which would be an even smaller decrease, and so forth. What we end up with is a curve. It's decreasing and concave up is what we're going to get for a graph like this. This is describing an exponential function. Remember, exponential function will have a fixed percentage rate of increase or fixed percentage rate of decrease, which is exactly what they've described here. The second sentence says they're projected to sell 4,500 widgets when widgets are free. This is describing a point on the graph. It's saying when the price is 0, when the input P is 0, the D of P, the number they sell, is 45,000 items. So we have a point and we have the percentage rate. The rate in this case is negative 0.042. Remember, you write your percentage rate as a decimal. And then we need to find, for the formula of an exponential function, what's called the factor. Factor equals 1 plus rate, so it's 1 plus negative 0.042, which is 0.958. And recall, an exponential function has the form y equals a times b to the x. A is your y-intercept, which we were given. That's the 45,000. And b is the factor, which is our 0.958. So for our function, it's d of p equals 45,000 times 0.958 raised to the, instead of raising it to the x, remember it's a p, 0.958 raised to the p power. In example 8, when XYZ company hired a new general manager, they found that revenue increased by 1.8% every month. If revenue is 1.9 million the month the new manager was hired, then find a formula for R of M, revenue, M months after the new manager started. So again, let's kind of think about this, figuring out our input and output, figuring out the type of function. They're saying we're inputting M and we're outputting R of M. M stands for number of months after the new manager started, and R of M stands for the revenue that month. I'm seeing in the first sentence, it's kind of similar to the last problem. It says revenue increased 1.8% per month. So if you pick a point on the function, if you go over 1 month, it goes up 1.8%. That's a fixed percentage increase. Again, repeats over 1 month. This time it would be a bigger increase because it's a percentage increase. So up 1.8%. Over 1, up 1.8%. Over 1, up 1.8%. What you're going to get here is an increasing concave up curve. Furthermore, the second sentence describes a point on the graph. It says the revenue is 1.9 million the month that the manager was hired, which is month 0. The revenue is 1,900,000. That's our R of M. So we have a point, which is the y-intercept. We have a rate this time, which is positive 0.018. We know if it's an exponential function, we need to have the factor, which is 1 plus the rate. So it's 1 plus 0.018. The factor is 1.018. So our y-intercept's 1,900,000. Our factor is 1.018. Exponential function is a times b to the x. So for us, it's R of m equals 1,900,000. It's our y-intercept times 1.018 raised to the m, because the input variable is m.